All right. Good morning, everybody. Thanks for coming. Looks like a fuller house again. I suppose you get your first walk on the show floor in, and now it's good to sit down a little bit. So, excellent. Thanks for coming to our landmark sessions here. This session is going to talk a little bit about, in fact, a little bit backwards here about smart grid and how that drove some developments in the building code in California. Some of you might have heard of that. I'll get to this in a second. And then our board member, Corey Gray, is going to talk a little bit about what's happening in the future in smart cities, aspects of safety and other things surrounding a smart city that's out there. So it should be interesting to hear from him on that. So I'll try and keep it short here so we have more time for Corey. But we'll quick show of hands. Who is sort of part of a city? Is somebody here from a city council or working on a smart city implementation? All right, perfect. Any integrators as well? Integrator companies that make it, yeah, okay. And otherwise, like product manufacturers, or what's the, okay, that's the majority here, I guess. Yeah. All right, excellent. Thank you. So I'm going to show a few slides in just a minute about the California Title 24. And these slides were passed on to me by Gabriel Taylor, who is one of the co-authors of the Title 24 specification in California. He's from the Energy Commission over there, very engaged in all of these aspects there. But before I get to this, just a really quick background for those of you that are not familiar with the California situation. We're seeing here that all of a sudden building code, in particular for commercial buildings in this case, reaches outside of the building. So it reaches over to the utility, to the smart grid. And there's a good reason for that. If you go back in time, if you remember that in about 2001, several West Coast states had issues with energy supply. So in 2001, there was an energy crisis that was pretty much, homemade, if you will, by some, not quite clean business tactics. And some of you might remember like the Enron scandal, right? Where basically, in a nutshell, and it was much more complicated than that, but in a nutshell, this company oversold the energy resources. So they had some reserves that they were able to provide to different states. However, again, very, very high level, there's a lot more to this. They tried to sell the same resources to multiple states at the same time. So as then multiple states needed the resources, it wasn't available anymore. So long story short, California had blackouts going on. The Silicon Valley had to darken certain areas of the cities, kind of cycling through the neighborhoods, so to speak. And of course, the California Energy Commission said, yeah, no, we can't really have that, right? So they wanted to have connectivity between buildings and the smart grid and have that more or less fully automated. Now, I should qualify for buildings themselves. It doesn't necessarily mean that everything has to be fully automated, especially if you think about larger manufacturing places and so on. Obviously, a manufacturer can't just turn off their manufacturing line. They would need to know how and when and need to know in advance and things like that. But coming back to more the residential as well as now in particular commercial buildings like office spaces, conference centers, hospitals, things like that, there were mechanisms in place to actually reduce the consumption of energy. So after this effort was done and there was a standard created that connects basically the smart grid with the buildings, the California Energy Commission then started to think further, okay, how can we make it so that in the future we'll have more and more of these resources on the building side available for the smart grid, essentially to help balance the grid with increased renewables. We are seeing much more fluctuation in the generation of energy. So we need to have some mechanism to really have the demand side, as they call it, follow these these load variances on the generation side. And that really only works if you can call on a building to respond to certain grid signals. And these grid signals could be both. They could be price signals. So it could be that the utility provides just simply a current price to a building, and your building automation system should be able, based on customer settings, to react to that. So with other words, let's just boil it, bring it down to, let's say, something that's more tangible for all of us. I think like your home, right? You may have some systems in your home that are not as critical to you, right? So you could set up, for instance, okay, first the pool pump will stop if you have a pool. The pool pump will stop maybe for 30 minutes or an hour or two. That's not going to do really anything. It's not going to hurt you. It's not going to impede you. And you can always also override it. If you have a pool party going on and you need your fountain to run, that's a different story then. But then there's other consumers in your home, right? HVAC, which you might not notice the first 15 or 30 minutes, but if it's a hot day, in particular also, of course, here, like in Florida, you have also the humidity, of course, that plays a role. So fairly quickly, you will start noticing if your air conditioning is not running or running at reduced capacity and things like that. And then, of course, in a household, you have multiple appliances and things like that. The latest big consumer, which should be mentioned because it also plays a big role in a smart city context, is, of course, EV charging. EV charging, obviously, has a huge load. One of the few really big new consumers of energy on both residential and commercial side. So these systems also, of course, contribute to the energy consumption quite a bit and can be curtailed or up and down regulated eventually. So what California did was they looked at the Title 24, and obviously I'm not a code expert per se, but Title 24 is a big framework, and many of you will probably even know that if you are working in building technology. And it encompasses pretty much all building code for both residential and commercial buildings. But here, in this case here, the Part 6 and the energy code really primarily targets commercial buildings. However, there are some aspects of the residential buildings that also fall into that scope. So again, I extracted these slides from Gabriel Taylor's presentation that he provided us and allowed us to use. So what does it really mean? Well, so first of all, as I said, commercial or non-residential buildings are affected by this. Any commercial building over 10,000 square feet, which is either retrofit or a new building, must be able to communicate with the smart grid. So with other words, you have to have automation in place in the building to control multiple different aspects based on grid control signals. And for instance, and I think we have it in a later slide, for instance, lighting systems. So a building must be able to dim, or I should say reduce the power consumption of lighting systems by about 30%, for instance, if you get a signal from the utility. So with other words, you do need to be able to manipulate your lighting in the building, of course. You need to be able to receive signals from the smart grid, right? So you must have some kind of a gateway, some kind of a controller that connects to your building management system in this case. Now, again, in some instances, this could also be a price message, but that is not necessarily in the scope of the Title 24. They don't necessarily care how or what kind of information you get as long as you can respond to grid commands. There's a few people standing. I think there's a few chairs still open if you want to find one. But right. So one thing to note is that in the context of the non-residential building, it also means high-rise residential buildings. So with other words, just larger apartment buildings and things like that are, according to this code, also commercial buildings in the sense, and then consequently also hotels and motels fall under that ruling. So again, Title 24 requires the building owner or the person that essentially commissions the building to be able to control the components inside using signals coming from the utility. So there's multiple aspects to this, of course. Again, first of all, HVAC thermostats is a big topic. But then there's others like lighting, as I already mentioned. Lighting needs to be controlled by 30% downwards and things like that. And all other building systems, really, from ventilation to other control systems that you have. Now, in addition to that, for multifamily, and there are some of these exceptions that I mentioned on residential, there are other aspects in there where you also need to keep an eye on the smart grid ready mechanisms that are required here. In particular, if you have, for instance, solar, right? So there's a certain solar ready requirement also in California that buildings need to be available for solar. But if you can't really do that, then you can at the same time also add controllable things like batteries, for instance. So you could have a demand response enabled battery in your building tied in with the building network that takes care of these requirements. So again, required for the typical HVAC installation, you definitely need to have automation built in for that communicates to the grid. There's a few of these paragraphs. I have to admit myself, it's not easy to read through these standards because it refers from one paragraph to the next, to the next, to the next, to potentially a different document, and there somewhere it says what you actually need to do. But I guess that's how these laws are. And again, everything over 10,000 square feet will need this for the lighting controls here. And then at the same time, in these electronic message centers, there also needs to be a significant reduction here of the power consumption. So these are just a couple of these examples where you see that that you definitely need to be able to shift your energy consumption. And maybe I should clarify that. That's why we have the slide in here. We are not talking about energy efficiency, right? Energy efficiency is one thing. Demand response is different. Demand response means you're shifting your energy consumption. You're not necessarily reducing your overall energy consumption, but you're shifting it away from peak times. Again, either peak times that are defined by the utility and they ask you to avoid using power at a certain time, or again, they give you just a higher price, right? If you have a peak time, they increase the price, they double the price. So your building might want to, respond appropriately to these price messages. So all of this again is there we go, required in the Title 24 specification. Again, if you have to deal with that in California, please take a look at these paragraphs here. And again, the same for particular solar-ready installations on the residential side. Now, for residential heat pumps, there are very, very similar requirements here, and we are also seeing a movement right now to better tie in, for instance, electric water heaters in general. So not only necessarily the heat pump ones, but the California Energy Commission wants to provide water heaters with current price signals. So it could also go through your automation network in the building, or they're also talking about, in some instances, more on the residential side, to bring this all the way down to the actual water heater on this end. So again, there's a few more of these paragraphs where you have some exceptions in here. And generally, again, it has to be ready for this. So I wanted to introduce this to just give you an idea of how building automation all of a sudden becomes much broader than just within within the walls of the building, right? And with that, of course, you're also thinking about the smart city. Where does it start? Where does it end? And how do buildings then really contribute to a city, both here in this case from an energy consumption perspective, but also from an overall data flow and really human interaction perspective. So I want to invite now Corey Gray over here to give us a little more insights on what is going to happen in the smart city space.
This is going to work.
Yeah, I'll use this. This is pretty loud. This is for the room.
Yeah, this is what I'm not going to stand there.
Oh, either way, I can turn this up. This is recording.
I might just hold on to this. It's a bit easier. Thanks, Rolf. As way of quick background, first of all, my presentation was very white because I told it just had to have no background, so I've been up modifying all of that. So we're involved in my organisation and with Longmark a lot more with thinking and thought leadership about how cities and how buildings in the future are going to interact with one another. And to Rolf's point, I guess you can see a very strong example where a major event in terms of electricity crisis has precipitated a change in legislation, which in turn has brought on a change in the requirements for all of us as building designers, installers, manufacturers, owners and operators. And so what I thought I'd do is spend a little bit of time now looking at what other contemporary issues are that touch a little bit upon this topic and move forward. I think we all know how big the Internet of Things is becoming, how integrated it's becoming with building systems, and how much it's changing the landscape of building design, ownership, operation and investment. And so I think we're all across the Grenfell Tower, what's making all this noise, Rolf? Right, sorry. I think we're all across the Grenfell Tower. The Grenfell Tower fire in London 2 years ago. Everyone's heard about that situation. I assume 74 people were killed in a residential apartment building. And at the time that came about, and obviously there's a royal commission going on to try and find out who to blame and who's going to pay, but clearly it's not going to bring anyone back to life. There's been several other very serious fires. The Notre Dame Cathedral, I think everyone's aware of as well. Most recently, there was another student accommodation fire in London, and so on and so forth. So we've been involved working with the chief fire safety experts and the fire safety engineering group in the University of Greenwich to look at that problem and say, because several of the issues that precipitated the massive loss of life was a very poor understanding of the building's condition in terms of extraction systems, hydraulic systems, systems that hadn't been maintained. There was no water in the pipes up to the top level, so it took 15 to 20 minutes for the firefighters to be able to actively start to fight the fire. And the general nature and spread of that fire outside of the initial compartment, which no one was expecting, meant that by the time the first responders arrived, it had spread through 14 levels of the building. And so they were inadequately prepared to attack that fire. So what does all that mean? At the moment, and this is, you can see where at the bottom there where the fire broke out, and that spread in 16 minutes that fast throughout the building, just for anyone who's not intimately acquainted with this catastrophe. And you can see at the bottom there were only, I think, 16 appliances when it was a completely inadequate response. So why am I talking about this? Because this is going to change legislation everywhere in the world. It's changing it in my country. I think probably everyone's aware that nearly almost all of it has burnt to the ground recently. And so there's a lot of discussion around the world. The chief fire safety expert to Grenfell Tower, as I said, we've been working closely with to try and find ways to address this catastrophe. He's also heavily involved in things like advising here at Congress on civil aviation safety, civil defence, and we've been looking at the first principles of what information we could get if buildings and cities could talk to one another to greatly improve the life safety outcomes, operational outcomes, and other things that stretch all the way into the capital value of assets and the price to insure them outside of the technology. But what technology is available that we can make those changes if buildings and cities can talk to one another. So in very simple terms, to give you a flyover of fire safety objectives, obviously you want to save lives. You want to be able to protect assets. I think an example more of asset protection is Notre Dame Cathedral, where there was, I think, no loss of life, but catastrophic damage to an historic asset. On the other side, you've got a fairly underwhelming apartment building, but 74 lives lost and many people injured. And then what we want to be able to do is provide to fire brigades and cities better information to make interventions. So what could we provide in terms of technology and information faster and in real time to be able to assist all of that? Very quickly, if there are any fire safety engineers in here, you'll probably understand this very well and be excited. What we're trying to do with smart devices is, as you can see here, reduce the detection time. How quickly between a fire starting and somebody responding can we detect it? In the case of Grenfell Tower, the first problem was that the apartment was vacant and the fire burned and burned and burned within the compartment and nobody knew. There was just an isolated smoke detector going off. The next thing we call in fire safety pre-movement time. That's the time from getting a detection if you're a fire warden to going and validating where a fire location is and being able to say, oh, someone burned the toast, or there is actually a fire, trying to put that fire out. Traditional processes, procedures around most of the world involve somebody getting a message on a phone or a pager, going to the fire panel, inspecting the fire panel, referencing the fire panel to a drawing that's probably not accurate. And you imagine if you're in this convention centre, then you've got to go as far away as Australia to try and see if there's a fire or not. So it's a very time-intensive process, and it's quite often, unfortunately, prone to human error and can be quite inaccurate. But our objective is to reduce the pre-movement time, and then if we ascertain that we need to evacuate the building, the movement time. All the time we're trying to drive a safety margin between the design requirements of the building and then the tenability requirements. That is when it's no longer safe to be in the building because either it's unsafe due to fire, smoke, or structural degradation. Now, there's a whole lot of things that touch this and touch everyone in the room in different aspects of what you're doing, whether you're making technology, whether you're installing it, whether you're managing it, or whether you own buildings. There's a whole lot of reasons that we want buildings to be safe. One thing we didn't talk about is business continuity, although we talked about processing equipment going down before. There can be huge costs to industry if a factory, for example, is fire damaged and can't continue to operate. A good friend of mine in Australia lost a meat processing facility that's been for 2 years being rebuilt at a cost of something like $3 billion of revenue because the processes in place weren't enough to maintain that asset. Asset protection is obvious, and this comes to a point which is again a bit left of centre, but the total cost to insure a building if you've got enhanced systems and technologies like this is very interesting to building and asset owners. If you give more transparency to insurance companies, then they can understand better the risk. They can see the risk is reduced and premiums drop down. So if you're talking to clients as integrators and building designers, this is very important. An unusual one, but a very important one, is environmental protection. When these fires take place, there's a huge amount of toxic chemicals and waste that's delivered into the environment, into the air, and also into waterways quite often. Another important one is inconvenience to people in a building. Where I think we've all been in a building where there's been a false alarm and everybody's evacuated. It's a staggering statistic, but 97% of call-outs for fire brigades are false alarms. So imagine what that means to the cost to government of resourcing that level of operation for no good purpose. Another really important part of putting buildings in touch with cities and governments is compliance transparency. What does that mean? Traditionally, if you want to make a building fire safe, somebody will come in, conduct manual tests, prepare a report, send a client an extraordinarily expensive quotation. But the reality is, any of us right now don't know if that exit sign works. We don't know if the smoke detectors or thermal detectors are working. But if you could have those devices be intelligent, and this is what we're getting to the point of where we think cities want to be in future legislation, the city can actually know that the tests have run, that the repairs have been made, and that a building is fire safe, which means they can make interventions on buildings that aren't. They can make public disclosures to people who are potentially going to occupy a building who are not safe. It can be used for, as I say, enforcement. For building owners, that can all be used for cost and compliance transparency with trade services providers. In the case of Grenfell, the service contractors had failed to maintain all of the pressurisation and air handling systems, which was hugely problematic in terms of evacuation because of smoke tenability, not just fire. If you've got an intelligent device, it will be saying every single day, my extraction system isn't working, it's not working, it's not working, either to government, to building owners, and or to residents and body corporate, to interested stakeholders. And this is a very simple process, and we've already started down the path with a few companies to develop this technology in response to the recommendations of the Royal Commission. At C-suite level, it's very important because right now there's a whole bunch of CEOs standing around in a Royal Commission for 2 years so far, with something like 3 years to go, who are directly and or indirectly responsible for those deaths and for that destruction of asset. So there's a high level of interest to the people who are going to be paying all of your bills and our bills to see this sort of technology come into their asset base now, because A, it protects their asset, B, it reduces the cost to operate their asset, and C, it significantly reduces their risk. And the cost of spending with service contractors who may or may not be as scrupulous as they should be and do all of the work that they need to do. NDIS is also for disability compliance. With some buildings that are being retrofitted, it's very important that you can have faster egress times and wayfinding for people with impaired mobility. This is very quickly the 6 areas that we've identified that need to be attacked. I don't know if this can be available for people who are interested, but I've put it there just quickly to move through. This is basically a flow chart of how you would fight a fire and the areas that we can help to reduce the detection time, the pre-movement time and the movement time, and also enhance fire brigade responses. And in a moment, I'll show you what some of these advantages look like. So if you're in a building or if you're on the way to a fire, if you're a firefighter, you'll typically arrive at the building, go to the fire panel and then work out where that fire is. If you have the right sort of technology, you can know on the way exactly which room the fire is in. You can see in real time the rate of movement of that fire. You can decide to come in this end of the convention centre, not the other end at the nearest point of the fire. You can also start to assess where you're going to evacuate people and where your nearest firefighting equipment is. And this is all incredibly valuable in terms of asset protection and life safety. Hopefully this plays. Just going to play video for me. This isn't going to play, unfortunately. It's very disappointing. This is a quick overview of some analysis of the beginnings of this on a public asset. This is a trial we prepared in Europe on train stations and shows the benefit of being able to have external control of egress. Again, you can imagine if there's a fire in this building, you hear an alarm and people try to get out. We know we'll go out this door, but at some point we need to choose to go one way or the other. And we wouldn't have any idea when that alarm goes off whether we're running into the fire or out of the fire. So having people externally who can then take control, to your point, like grid management, and move into the building and actually tell us which exit to take is extremely important. And so active dynamic signage systems for wayfinding are, I'm sure, going to become a mandatory part of building design and building interoperability with cities, because you can see here, just by helping people make decisions, by that exit sign having a cross come over it and this one turning green and saying exit here, people can get out of buildings up to 94% quicker in all of the academic research that we've put together on this topic. So there's huge goodwill at government level, there's huge need at industry level, and it's something that will, over time, in all the different jurisdictions roll out, I'm sure, to be a requirement, again, for interoperability of building and building systems into with cities and municipalities. Unfortunately, these videos don't show you, but what can be operated now is that this exit sign will actually strobe green, which significantly increases the likelihood of people seeing it. We have a big problem in building design of what's called learned irrelevance, is that we see things so often that we don't see them anymore. It's hard to believe, but in a study we did, only 36% of people, when put in a room like this, saw the exit sign. And so, I mean, if you look around, you think that's crazy, but people are so used to seeing them that they don't see them anymore. The other thing is that most people, if they come into this room through there, will try and get out through there without noticing that there is a far easier point of egress. So again, with a directional sound, you can actually hear the exit sign. This can be operated externally or by fire panel interface, and we can move all people safely out because the fire's outside those two doors. So the sort of, oh, it is playing. So that nearly threefold increases the likelihood of somebody seeing a sign. On the other side, as I say, if the fire is the way we came in, hopefully this is going to work for me, you'll automatically get that. So people can plan the evacuation of a building on the way by being able to interface and take control of a building in the same way that in energy you can have demand side management. People can start to direct people out. So you can see perception increases significantly. In the research we've done, 90% of people understand what that red cross means, irrespective of language or cultural difference. 66% of people in the variable condition chose this nearest exit instead of the one that they came into. Otherwise, 100% of people will choose the door they came into nearly. And most of all, decision-making time reduces. That doesn't sound like a lot, but if you've got to make a lot of decisions to get out of here, you know, you're looking at a factor of 25% time saved on each decision, but most importantly, decision accuracy moves to 100%. So all of this together means, depending on the nature of the building, if the fire brigade has access to this building data, they can know that the systems are working and they can evacuate people significantly quicker. This is another example of technology we've been building where the fire brigade on responding can see what levels of a building and locations people are in and see their movement to evacuation, for example. So when you're planning the rescue response, not just the fire attack or the fire response, it's much easier for people to plan. And this can be put onto the building drawing set so that you can actually see the movement of the people in a building as they're evacuating. I don't know if you can see there, but you can also see if there's mobility impaired people who might need additional help. In Grenfell Tower, there's one gentleman who couldn't walk and the elevators weren't working, so he couldn't get out, but nobody knew that he was mobility impaired. You can also see which of the people are fire brigade and responders. So this level of information in terms of the rescue response by fire brigades, by having that data going out again and the building talking to the city, makes a huge difference. If you have a civil defence problem and potentially you have 4 skyscrapers in New York, they might all have a fire plan individually to evacuate into one common area. But if all 4 buildings evacuate at once, you won't be able to get all the people out. So again, you might want to change the evacuation plan on that basis. So as I say, again, whether you're in the building or you're a fire officer, and you can arrive, know what level to go to, see where the fire is. This will update if the fire is expanding, but importantly, you can see where all the fire response equipment is and know where it's working and see where the exits are. So again, instead of arriving and having to try and guess your way around a building, this level of information proves invaluable in the life safety response. I mentioned briefly, and then I'll sort of wind up on this. As I said, we just want to give an example of what the future of smart buildings and smart cities can look like, and safety is a key driver and crisis type events. But what else this will do is store all the information off site for a client that you can see. As I said, if your service contractor has done their work or not done their work, if systems are working or not working. In the case of Grenfell Tower, there were 2 systems that were dysfunctional that would have been repaired to at least enhance that response had this sort of information been available to building inspectors and building managers. So, as I say, the summary is that there's a whole lot of opportunity now with Internet of Things to enhance building systems, whether it's HVAC, lighting control, electrical management, life safety systems, hydraulics, a whole lot of things. And one of the things that drives this is, of course, crises and major catastrophes. So this is another example about where we're going to start to see legislation that changes the way we design buildings, the way we manage and build buildings, and then interact between municipalities and all other building stakeholders to deliver changes in the built form for the future, with impacts for, as I say, owners and investors, a safer building. There's even talk at the moment of having a public rating, like an energy rating for a building, which is a safety rating, a fire safety rating. We talk a lot, for example, to people whose kids go away to college and stay in student accommodation and what have you, and you want to know that that building's being managed and is safe to a level that we're all wanting, I think, to benchmark now that we understand the significance of all of these things. So that can add to market appeal, building value, as I say, lower insurance premiums, and significant asset protection and life safety benefits. So, as I say, that's just one other example from what Rolf's talked about how IoT and building automation and systems design is going to change the way that we do what we do. And I hope, it's a little bit of something to think about in terms of what other areas as well that we're going to see these sorts of changes with. Access control will be another one, I'm sure. So I'll wrap that up there and let Rolf talk again, although you'll need to.